product of oxidation depends upon the concentration of nitric acid and the condition of that reaction. The carbon is a non-metal. Reacting with HNO3, it forms a carbon dioxide, water and NO2 gas will be released. Dinitrogen oxide is a colorless gas and it is neutral. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called PBLOCK element. Under that, we have discussed about the compounds of nitrogen by understanding the preparations of ammonia, and also we have discussed about the physical and chemical properties of ammonia, and also we have discussed about the uses of ammonia. In addition to this, we have also learned one of the important compounds of nitrogen, that is nitric acid, and their preparations we have learnt. Today, we'll move on to the next topic of this unit by understanding the physical and chemical properties of nitric acid. So again, how we have studied in case of ammonia, like that we are going to study the physical and chemical properties of nitric acid here. And also, one of the important tests known as brown ring test, which will be more familiar to you, because in the detection of nitrogen, in the brown ring test, where you have learned that in the laboratory how to do with the brown ring, the same thing we are going to discuss here. And also we are going to discuss with the uses of nitric acid, and we are going to learn with the oxides of nitrogen and structure and the oxides of nitrogen we are going to understand. Okay, we'll see what is the physical properties of nitric acid first. Okay, so again, anhydrous nitric acid is a colorless, fuming and liquid which is having a pungent smell. Hope you know that the concentrated nitric acid will always have a pungent smell, and it is also fuming. What is the fuming here? The fuming which indicates that these are the liquid, when it is open, it gives rise to the gases. Hence it is known as fuming liquids. And laboratory grade of nitric acid, which consists of nearly 68% of nitric acid by mass with specific gravity around 1.504. So this is, I am talking about laboratory grade of nitric acid. Okay, it consists of how much? 68% of nitric acid by mass with a specific gravity. Okay, next we have a chemical properties here. We'll see how does this nitric acid will also react with the metals as well as with the other things. First, I'll go with the oxidation of metals. Okay. First one, the concentrated nitric acid is a strong oxidizing agent and it attacks the most of the metal except noble metal such as a gold and a platinum, and the products of oxidation depends upon the concentration of acids and the condition of the reaction. Here we have a first reaction with the copper metal. Okay, so this is a copper metal where it is reacting with HNO3. I am talking about dilute HNO3 under cold condition. What does it form? It forms a copper nitrate with a nitric oxide and formation of water molecules will be formed. But again, if you carried out the same reaction by considering the concentrated nitric acid, the reactions will be different here. You can understand that copper reacting with concentrated nitric acid under the same cold condition, it forms a copper nitrate with nitrogen dioxide will be formed and water molecules will be released out. This indicates that the product of oxidation depends upon the concentration of nitric acid and the condition of that reaction. So this is a most important one where you are going to understand that even though we are changing the concentration of the nitric acid, the reaction conditions and the product formations will be different. Okay. Next we have one more reaction, that is reaction with the zinc. It's a reaction with the zinc are as follows. So zinc reacting with dilute HNO3. I am talking about only 20%. Okay. Then what will be the product? It forms a zinc nitrate with the formation of N2O and water molecule. What is this N2O and NO2 structure? We are going to discuss at the last. Okay. Same reaction if you carried out by considering 17% of concentrated nitric acid, it forms a zinc nitrate and nitrogen dioxide will be formed and along with the water molecule. Again, there's reactions which are showing that even though you are changing the concentration of the nitric acid, the product which is undergo oxidation, it will be different. This indicates that our nitric acid is a strong oxidizing agent, thereby it can easily oxidize the metal, but it does not react with some of the noble metals like gold and platinum. We have the oxidation of non-metals also. The concentrated nitric acid can also oxidize the non-metal and their oxides or with the highest oxo acids will be formed. So first I'll go with the non-metal by considering the iodine which is reacting with HNO3. It forms a HiO3 with the formation of nitrogen dioxide and water molecules will be formed. Similarly, the carbon is a non-metal reacting with HNO3. It forms a carbon dioxide, water and NO2 gas will be released. Similarly, the sulfur and phosphorus reacting with concentrated nitric acid, thereby it forms a sulfuric acid and H3PO4, that is sulfuric acid and hydrogen phosphate. Thereby it forms a nitric acid and water molecules will be formed. This indicates that even though you are taking the non-metals, okay, these are the non-metal, our nitric acid is also oxidizing. Here also it is act like a very good oxidizing agent. It is also acting like a oxidizing agent. Thereby, it oxidizes the non-metal and forms a respective oxides, and sometimes it also leads into the formation of oxo acid where H2SO4 as well as in H3PO4, oxo acid means this is a complex compound which has been formed between the oxygen and nitrogen. So thereby it indicates that it also forms a oxo acid and also it can form the oxide. This is how the nitric acid, which shows their different nature with the metal as well as with the non-metal. Remember, when it is reacting with the metal, it forms a oxide. When it is reacting with the non-metal, it forms what? Even though it forms oxide, it also forms a oxo acids. Some of the metals like aluminium and chromium do not dissolve in concentrated HNO3 because of the formation of passive film of oxide on the surface. Hope you know that with the aluminium. This is a most important question which has been asked many times. Why aluminium does not react with concentrated HNO3? Because when you dissolve the aluminium in the concentrated HNO3, it forms a thin film around that metal. So that is why it do not react with the HNO3. Thereby it forms a passive oxides on their surface. Next we have brown ring test. First, we will understand brown ring test. Later, we'll recall it how we were doing with the laboratory. Okay. It is also used as a confirmatory test for the nitrate ion during the qualitative analysis of inorganic salts. Already I have explained that in a group 2, while doing the group identifications, we will confirm that nitrate. To confirm it once again, we will go with a confirmatory test. Thereby, we will do the brown ring test for the nitrate. Is it right? Yes. So, what does it forms? So, nitric oxide reacting with the iron in presence of H plus ion, it forms a nitric oxide and iron which get oxidizes to Fe3 plus with the formation of water molecule. And this iron with the water molecule react with one more nitric oxide, it forms a brown ring solution and it will form a water molecule. Hope you know that while doing this brown ring test, the brown ring will be immediately comes and if you shake that solution, it will be go off because it forms a brown ring immediately. So, we will understand how we have done in the inorganic salt analysis. First, you will take the salt solution of given salt with a dilute ferrous sulfate solution you are going to add and concentrated sulfuric acid if you added along the sides of the test tube, which forms a separate layer at the bottom. To the test tube, you will add the salt solution and you are going to add ferrous sulfate solution FeSO4, okay, which is freshly prepared, and you will add what? Concentrated sulfuric acid H2SO4. If you add this at the bottom, this formation of brown ring, this indicates that nitrate is conformed on your salt. This confirm the nitrate on the salt. Thereby, we can clearly say that this will be belonging to the group 2 in that nitrate is present. Okay. Like this, we will do the brown ring test to confirm the nitrate which is there in the inorganic salts. Okay. We'll go with the uses of nitric acid. Okay. Nitric acid, again, it will be used in manufacturing of fertilizers like ammonium nitrate, and with a basic calcium nitrate will be prepared by using the nitric acid, and in the manufacturing of explosives like TNT, that is trinitrotoluene and picric acid, and also in nitroglycerin and in a dynamite. Not only it is used as a fertilizers, in the explosive making also it will be used, and also in the manufacturing of artificials, dyes, drugs, as well as in the perfume. And in the laboratory especially, we will use the concentrated and dilute nitric acid. Concentrated and dilute nitric acid. Hope you know this. Okay. Now we will understand what are the oxides of nitrogen. First, I'll go with the dinitrogen oxide, which is also known as what? Nitrogen 1 oxide. Okay. So, nitrogen 1 oxide or dinitrogen oxide. So, oxidation state of the nitrogen in dinitrogen oxide is +1, where the common methods have represent and their physical appearance. First, I'll go with the common method. Ammonium nitrate, upon heating, it gives rise to the dinitrogen oxide with a water molecule, and this dinitrogen oxide is a colorless gas and it is neutral. This is the first oxides of nitrogen. Coming into the nitrogen monoxide, it is also known as what? Nitrogen 2 oxide, which is represented as NO. In that, nitrogen will be exits in +2 oxidation state, and the common methods will be as follows. Sodium nitrate reacting with ferrous sulfate solution in presence of concentrated sulfuric acid, it forms the iron sulfate, sodium hydrogen sulfate with a water molecule, and nitric oxide will be formed. Again, it is a colorless gas and is neutral in nature. Okay, and we have one more oxides of nitrogen, that is dinitrogen trioxide, which is also known as nitrogen 3 oxide. So in this, again nitrogen will be exits in +3 oxidation state, and the preparation process will be goes like this. Nitrogen oxide reacting with N2O4 at 250 Kelvin, it forms a nitrogen trioxide, and again it is blue solid and it is slightly acidic in nature. Coming into the nitrogen dioxide, okay, nitrogen dioxide, which is also known as nitrogen 1 oxide. In this, nitrogen will be exhibits in +4 oxidation state, where we have a separate preparation method, that is PbNO3 twice, which gives rise to the NO2 and PbO. Thereby, it indicates that nitrogen dioxide will be formed. Okay. Next, we have nitrogen monoxide, which is a NO, which is having +2 oxidation state, where we can indicate this by writing the nitrogen dioxide, which is upon heating, it gives rise to the N2O4, and again it is a colorless solid and liquid, which is acidic in nature. Coming into the dinitrogen trioxide, which is N2O3, which is having +3 oxidation state, the HNO3 and P4, PO, which gives rise to the PHO3 and N2O5. Again, it is a solid and acidic in nature. Next, we have the structure of oxides of nitrogen. So here we are going to understand how does the level structure of oxides of nitrogen will be looks. So first I'll go with the N2O, that is dinitrogen oxide. So here the resonance structure will be goes like this. Between the two nitrogens, sometimes we will have a double bond or with a triple bond. But if it is a double bond between the two nitrogen, we also have a double bond with the oxygen. And if it is a triple bond between the two nitrogen, we have a single bond with the oxygen atom. Thereby it exhibits the resonance, two resonance structure, and the bond length or as follows. Between the two nitrogen atom we have 113 picometer, and between the oxygen and nitrogen we have 119 picometer, and it exhibits in the linear structure and it looks like this. It is linear. Coming into the nitric oxide, so it is NO. Between the nitrogen and oxygen we have a double bond. So thereby it exhibits the bond length around 115 picometer between the nitrogen and oxygen. We have N2O3, that is nitrogen. There are two nitrogen and three oxygen atom will be there. Between the two oxygen atom we always have a double bond with the nitrogen atom. Thereby it exhibits a single bond with the other third oxygen atom. Bond length are as follows. Between the oxygen and nitrogen atom we have 105 degrees Celsius and bond length will be 114 picometer. Between the nitrogen and nitrogen we have 186 picometer, and between the nitrogen and oxygen again we have a bond length around 121 picometer, and the bond angles will be various here. Between the nitrogen and oxygen we have 117, between the oxygen and nitrogen we have 130, and the structure will be planar, and you can understand this structure. It is planar in nature. Next, coming into the nitrogen dioxide, where nitrogen is a central metal atom surrounded by two oxygen atoms. Thereby, one oxygen atom will be having a single bond, other oxygen atom will having a double bond. Thereby it exhibits only two resonance structure and it is angular in shape, and between the two oxygen atom we have a bond angle around 134 degree, and the bond length of nitrogen and oxygen is 120 picometer. Here also it is 120 picometer. Coming into the N2O4, there are two nitrogen atom will be there surrounded by 4 oxygen atom. Thereby it forms a N2O4 and it forms a planar structure. You can see that between the two nitrogen atom we have a bond length around 175 picometer, and between the two oxygen atom we have 134 bond angle and the bond length will be 121 picometer. Lastly, we have N2O3. We have 3 oxygen atom and 2 nitrogen atom. Thereby you can clearly understand that between the two nitrogen atom, like a bridge, third oxygen atom will be exits and it forms like a bridge. Okay, and thereby it exhibits a planar structure. Again, the bond angle between the oxygen and two nitrogen atom is 112 and bond length will be 151, and between the nitrogen and the oxygen we have 119 picometer bond length, and between oxygen atom we have 134 bond angle. Thereby I have completed the oxides of nitrogen by understanding ammonia as well as the nitric acid. In the next class we are going to understand more about the phosphorus, which is the second elements in the group 15 elements. Till whatever I have taught, it is a group first element, that is a nitrogen, and the compounds of nitrogen also we have learned. And in the next class we are going to understand what is a phosphorus, what is their occurrence, what is their electronic configuration, physical and chemical property, and the compounds of phosphorus we are going to understand. By this I wind up my session. In the next class, be prepared with what are all the things which I have covered in this session, and mark the important questions which is frequently asked in your examination. Till that, take care, be safe. We'll meet you with the next session. Thank you.